Morning, everybody. So, huge crowd. I love it. AWS Security compliance, near and dear to my heart. So I like to have kind of three sections of this talk. First is kind of going over a little bit about my background. The second is Flatiron and the kind of problems we try to solve and how that informs our AWS security strategy. And then the third is how we think about AWS continuous monitoring and our security posture. So kind of quick bio on me. I spent most of my time in the intelligence community as an engineer building cyber data lakes. We used to call them SIMs back when that word was cool, but now it has to be a cool data lake. And I spent a lot of that time looking at trying to answer questions from all the different teams. So threat intelligence teams, insider threat, the internal audit team, the SOC. And what I found is that if you spend a lot of time thinking about the question before you try to jump in the data and decide if you're secure, that's really the difference maker. So I'll give you an example. I used to get a question a lot of how many blocks have we had in our firewall in the last month or last year? So I rev up our either terabyte or petabyte scale data lake and answer this question over the course of a year. And then I get really sad because then I would see that in a slide deck of here's how many attacks we faced. We faced 1 million attacks and we blocked them all, right? So the question of how many blocks we had was really not the right question. It was about what does the attack landscape look like? So from there, I moved on to Capital One as the director of global cybersecurity operations. And I had 4 teams of incident response, security operations center, and the data engineering, which was our data lake, as well as a DevOps team. So again, it was pretty challenging to get the right questions asked and drive the conversation. So from here, let's kind of talk about Flatiron. So our mission is pretty ambitious. We want to improve lives by learning from the experience of every cancer patient. So what does that mean? So a key part of how we do this is our OncoEMR product. So essentially, if you're an oncology clinic or a hospital, you need to have software that helps you do healthcare operations more effectively. And so when you get treatment, you have this very structured data that the doctor can use to measure your progress throughout the treatment. But what we've learned very quickly, and why Flatiron exists, is that there's a whole lot of data that can't get captured in this structured way. There's unstructured information that can be the key to determining how well you're responding to a particular treatment. So when you think about learning from all the cancer patients across the US, you have to be in a lot of clinics. So basically we have 2,500 clinicians that are using OncoEMR. There's 500,000 patients who are being treated by it every single month. And there's over 800 unique sites of care. So with all this network of oncology clinics, what does that translate to from a data set perspective that could be useful? It's going to be around 2 million people. So kind of back to this concept of structured versus unstructured. So once you get all the data into a format you can use for research, how do you unlock the unstructured aspects? So there's kind of the normal things you fill out when you go to the doctor's office, your address, your name, what you're there for, maybe some of the medications you're on. But then there's this other information like radiology reports or discharge notes or handwritten notes by a doctor. And again, the key is that information is critical for life science partners to understand how well their treatment or drug treatment is working. So here's an example of that. So this data down below, like these typed out notes, you're not going to be able to store that in a field when the doctor is seeing you, because doctors have such limited time with patients and they have so many patients to see. So, but at the same time, you need to be medically trained to properly understand this information. And someone who can do that typically is called an abstractor. So what will an abstractor do? They'll go through all of this unstructured data, these charts, these photos of radiology reports, and review and analyze and summarize that information, and then put it back into a structured format. And so you really need a large team of abstractors who are doing this, and that's one thing that Flatiron's been able to achieve, is being able to process all this unstructured data at scale. So the end result is you have the largest real-world oncology data set in the world. So this term, like real-world oncology, let's kind of dive into that for a second. So clinical trials, I don't know, hopefully most people don't have experience with that, but essentially to get through FDA approval, you have to get representative samples of patients across the US, and it's a very difficult thing to gather the right people in the right places. You have geographic limitations. And the big principle is that you need to have a control arm. So how does a patient react to medication compared to a patient who doesn't take that? And so you have kind of the entire population who is not taking that medication, and you'd love to know like how they're reacting to it. And that's what we call real-world oncology data. So basically taking the experience of everyone who's going through oncology clinics and using that to inform trials and drug studies. So from a customer perspective, we have the life science partners, and also research institutions like National Cancer Institute. And then as far as, so Flatiron's around 500 people right now, and if you look at the kind of distinction around the technical skill sets, we really combined engineering and development with people who have very technical medical backgrounds and skill sets. So that's why you see Duke Cancer Institute, Aetna Health, combined with like Google and Amazon. So putting those two domains of knowledge in the same room and working very closely together, we found to be a really effective way to deliver a product that is very useful for the life sciences community as well as on oncology clinics. And then just kind of a little background on Flatiron. So 2012, company was founded. Google Ventures and Roche both had significant investments that have really accelerated the growth and the progress of the company. So like I said, we ended last year with around 500. We continue to heavily invest in expanding more engineers, and we always have open positions. And we're also just right down the street. So this is kind of the last slide on what Flatiron is. So another way to just say it in one sentence is that we're building the technology platform that will enable us to learn from the experience of every patient. All right, so now to kind of transition to the AWS security aspect, since 100% of our business is in AWS. So I spent a lot of time thinking about questions, what questions to ask, because just like requirements of a project, if you ask the right security questions up front, it really can make or break the difference in my view. So first I'd say, what is your threat model? And the threat model is an incredibly important conversation because oftentimes you'll see that solutions or security controls or requirements are not solving for what people think that they're solving for. I can give you an example. So I've worked at a place previously that was basically saying, all right, AMI rehydration. We're going to use that because it makes us safer. Okay. but what is the actual threat you're protecting against? And then it morphed into, we're going to use that for prevent persistence and lateral movement and targeted attacks for adversaries who are trying to get a foothold in our network. But the challenge with, like, AMI rehydration is a great practice and you should do it, but a challenge if you're applying that to that particular threat model of having a targeted attacker, you end up asking yourself, okay, in what ways can an attacker persist on your server? And Google MITRE ATT&CK framework, look at the persistence methods, you'll see the startup folder, you'll see registry entries, and you can say, okay, so when people are performing rehydration on these Windows machines, what are they typically doing? Well, they're saving their startup folder to an S3 bucket, they're loading all their services that they had running previously, that way rehydration doesn't disrupt them. So really, like, AMI rehydration is a great idea, but it's not solving the particular threat in your model. So another way to, like, break down the threat model is to say, what is the sensitive data, and how do people access it, right? That's like the most first principle question. And so how do you think about sensitive data? Well, the best way to do it really is to, if you're in a regulated industry, is go find out how a breach is defined. So in HIPAA, a breach is defined very specifically. It's a impermissible use or unauthorized disclosure of PHI, protected health information. And PHI has 18 criteria, and for something to become not PHI, it has to be de-identified through two methods, either safe harbor or expert determination. So this kind of in the weeds governance regulation stuff is, like, incredibly important to your threat model, because if you're trying to protect all things at all times, obviously that's not going to work. So there are areas where you need to, like, really do a deep dive. So the next part is you're in AWS, you're in the cloud, and, like, it really is, like, living up to the hype. Like, people can spin up new services, deploy new technologies, play with everything, and how do you keep up with that? So traditionally, you would say, okay, I'm gonna have a third party come in, do a security assessment, or I'm gonna get a checklist from NIST or PCI or COBIT, and once a quarter kind of go through my security posture. But does anyone think that paradigm still works for the speed of the cloud? So I want to kind of change gears for a second. So there is a Q&A after this, but I also prefer conversations and not lectures. So has anyone had success in that paradigm? So it sounds like probably not. So what I would advocate for is you need a way to continually assess your security posture and as close to real time as possible. And you really can use whatever framework you want, whether it's AWS CIS benchmarks or NIST standards or PCI, but you got to have that baseline. And the approach isn't to just follow a checklist and say you're secure. The approach is to see what flags in an automatic fashion, and then do a risk analysis based on your business processes and what you care about from a business priority standpoint, regulatory standpoint, and then, and then basically get your baseline of, okay, I essentially know here are the 25 things that should never change. Here's the 10 things that can change from time to time. And here's the 10 parts of the benchmark that really don't apply to me, I don't care about. So I would advocate you need a tool to deliver this in an automated and very real-time way, because it's very time-consuming to, if you were to manually do this and check every config in AWS to say, all right, is this following one of 55 best practices? So the last one is what I'd say is kind of the paradigm shift. So how do you build bumpers instead of blockers? So I would argue that when I say bumper, you could think of it like in the bowling alley, when you're trying to, learn to bowl, you're a little kid, and it's a lot more fun if you have a bumper as opposed to just throwing it in the gutter. So it's a gentle, push in the right direction, but keeps you on track. And blocker, I think, is something that legacy security teams are being forced to change, because if you're, just the no, if your answer is always no, if your, icon and mentality and logo is a big lock, you're really, it's the worst of both worlds, because your security staff will become disillusioned because the business will essentially say, all right, well, they're always the blocker, and it creates a very adversarial situation between the business and the security team. So I would say the successful security teams absolutely learn to partner and enable the business. And the successful businesses understand that you can't outsource security to your security team, that it absolutely has to be a partnership. So how do you design for bumpers instead of blockers? I think one way to do that is for any given AWS resource that you're looking at, whether it's EC2 instances, setting up VPCs, looking at RDS, Redshift, any new latest and greatest technology, first start with what is it that we'd be okay with users doing? So, and then start with how do we make that behavior okay? Because generally we know what developers want. They want to move fast, they want to play with the technology, they want to spin it up. And so, it's very, if you start up front, it's pretty straightforward to say, all right, I'm going to create a sandbox environment where, I don't have to worry about all the tooling and restrictions. I'll have a baseline of logging. So you want to be able to kind of go back to the fundamentals on that. And another part is, doing the diffs on the config and fabricator and reviewing changes. You also want to identify where can automation pull security out of the process as a blocker. Because if security is constantly having to review every single change, like you're going to burn out the security team, and developers are also obviously going to have a pretty awful experience. So from an automation standpoint, you certainly can enforce via Lambda functions, enforce via asset tagging, and I'd say just kind of overall, it's this notion of secure by design. You want the developer, you don't want your security strategy to be based on hope. You want people not to be able to make mistakes in your AWS environment. And you can do that by creating these bumpers and these guardrails, as opposed to just this kind of handcuff model or this security has to review everything model. So when everyone was migrating to the cloud, and many people still are, but certainly over the last 4 years, there's kind of this big hysteria, oh, it's the cloud, it's totally different. And yeah, it is different in a lot of important ways, but there's always security principles that will never change. And two of the biggest ones that I think usually do not get enough time spent on is core principles of where's your sensitive data, where does it live? And I think the reason it doesn't get enough time is because it feels kind of boring and it's hard to do really well. I think it goes back to understanding how you define sensitive data. And then when it comes to where does it live, one of the best things I've seen is just sending out a Google survey to your workforce that takes less than 5 seconds to complete, and you basically say, okay, we're just kind of reconfirming all the workflows. And a little survey like that, is much more cheaper, or a lot cheaper and more efficient sometimes than doing a full-blown assessment with third-party auditors. Same question down below. Where are your critical assets and where do they live? So you're always going to have different levels of maturity for different teams, different organizations. And security would be super easy if you walk into an environment and you have dev, staging, and prod, and that everything in prod is always prod and everything in dev is always dev. But I've been at 3 different industries and many different organizations prior to that as a consultant, and it's never the case. And I think there's a lot of kind of economic reasons for that. when you're moving fast and iterating, whether you're in a small company or a big company, it takes time to stop and do some of these things correctly. So you are paying down tech debt. And I'd say like the third principle just goes back to once you know where your data is, once you know where critical assets are, then your threat model is much more informed, and it's a lot easier to make these decisions. So again, what are the unique AWS security challenges? So absolutely speed, velocity, and attack surface. So I guess one question to the audience is, when you look at all the AWS resources available, do you look at it and say, for each resource, you'll want to define security controls that have to be there from a requirement standpoint, or is it more like broad? So has anyone kind of looked at when they're trying to bring on a new AWS security resource, what are the steps that they do? Yes.
One of the approaches that we took to solve it holistically is our security team can't be everywhere, every time in the cloud, right? It's just way too dynamic, and we have two sets of development teams that have two different AWS accounts. It'd be impossible to manage. But what we did do was install a tool that, to your analogy, it puts up bumpers, and it's real time. So anything that goes out of a set of rules that we define, or rules that are defined by CIS or one of the other standards, then it immediately sends an alert to us, and then we have a discussion with the development teams. So we're not impeding their progress, we're not blocking it, but yet we can see everything at a 50,000-foot view level, whether it meets a certain criteria or violates a certain criteria, like a HIPAA or an IS, something like that. So that, I'm not saying that works for everybody, but at least that's what we did, because DevOps is certainly going to know the intricacies and the automation way better than a security team, and we don't have a SecOps team that can go deep into those weeds. So.
Absolutely, yeah. I just kind of summarize that answer. That was spot on in my experience as well. It's getting visibility, and if you have security people that understand the DevOps process, that's a force multiplier, and you absolutely have to become best friends with your DevOps team, because understanding how Terraform and Ansible and CloudFormation templates, how they can affect your posture, your visibility, and be able to respond is critical. I can give an example. If you're trying to solve a simple logging issue of you want S3 buckets, every S3 bucket you want access logs. So, on the surface, it seems like a pretty simple solution. You could log into the console and manually enable it. You could write some Ansible scripts. But again, with this speed, velocity, and kind of independence that developers want, a lot of times they'll have their own Ansible scripts. And if they're, if you want to influence every single S3 bucket, that means you have to catalog and modify every single Ansible script in your bucket that could be used in that process. So, on the one hand, you can touch everything in AWS. Through infrastructure as code, that's fantastic. But on the other hand, where those security issues can lie, it can be highly distributed. So I'd like to move on to a quick little kind of case study around S3 buckets. So S3 buckets should keep everyone up at night. I'm assuming every month there's, someone left their sensitive data in an S3 bucket, and now the internet has it, and now you've breached. So here, what I'd say when you're talking about the risk presented by S3 buckets, this is where fundamentally goes back to threat modeling. So what are the sensitive data that could be in the S3 bucket? How good is your naming convention? How confident are you that you know exactly where the S3 buckets are going to exist, and you have the right telemetry, you can control them? Then I'd say, what are the potential breach factors you're trying to prevent? So obviously one is a misconfiguration where it's publicly available. Another could be many people have access to that S3 bucket, and that S3 bucket has sensitive data. So now you're looking at potential account takeover from these privileged users. Another could be, how do you look at access to an S3 bucket? Is it just the access key? Does that key get rotated? Does that key require two-factor authentication? So that way, if someone has the key and they're not using VPN or they've left the company, then it's clear that the access to that resource is gone. So, and then the last part is, let's say all your preventive controls fail, how can you still recover in a resilient way? So if you have an S3 bucket open and you have to kind of go to your leadership and say, yes, this was open for 2 months. We have no idea who accessed it. We have no idea what they accessed inside the bucket. That story is pretty awful. But if you can say, yeah, it was open, which shouldn't have happened, but it did. But we actually identified this in the last 7 days, and we have full logs showing that actually no one accessed it. That's a much different story and much different conversation. And then you always get more granular of what logs you need from the S3 bucket. Do you need the access logs or do you need the object level logs? So obviously object level will tell you what was being downloaded versus access of just who. And then you obviously, when you're looking at maturity from this kind of solution, you start with a policy of all S3 buckets have to be created by specific people in the organization, or you could then also say, we're going to loosen up the policy, but we're going to have technical controls in place. So if you're able to influence every Ansible playbook to ensure that S3 buckets are only created in the right way, or if you can't prevent it, then you can look into your automation through Lambda. So can you get an alert that an S3 bucket, an event occurred of it writing to global, and then fire a Lambda function to automatically contain that S3 bucket. So I guess the point of this kind of case study is identifying all the different threat vectors, identifying the kind of sophistication of the attacker, whether it's account takeover, whether it's accidental exposure, whether it's intentionally malicious, and then going through around, can you completely prevent it? If you can't prevent it, can you recover? And if you can't prevent it and recover, can you at least alert on it and close it off in a meaningful amount of time? So I guess I kind of say to kind of sum up this entire talk, it's about getting visibility. It's about continuous monitoring of your security posture, because that's essential, because your security posture can change instantaneously with the speed of DevOps and infrastructure as a code model. And then it's about moving to a state where you're secure through automated guardrails.